So first, I'm going to do a small introduction about Wi-Fi 7. It's mostly a repeat of the Wi-Fi 7, why do you want it presentation I did a few months ago. But anyway, I will repeat that part now. Also, I will show you my face. So after the Wi-Fi 7 introduction, I will talk about the access points, and after that, a little bit about the roadmap. And well, you can ask any questions in the question thingy during the presentation, and if I notice them, I will try to answer them immediately. If not, I will do it after. So Wi-Fi 7 is great, of course. It's new, it's shiny. So Wi-Fi 7 is intended mainly to improve the efficiency and throughput of everything. So that is what where we're going for. Reliability is another thing, and reducing latency is the third thing that we want. Everybody wants to achieve with Wi-Fi 7. The interesting thing about Wi-Fi 7 is that just like Wi-Fi 6E, it is also supposed to operate on 6 gigahertz. That said, it's not certain that all Wi-Fi 7 APs will be tri-band. They may be 2-band or even 1-band. And in case of 2-band devices, maybe they will operate on, so say 2.4 and 6 gigahertz, or maybe even being switchable between 5 and 6 gigahertz or something like that. Wi-Fi 7, of course, is backward compatible with previous Wi-Fi versions, at least from Wi-Fi version 3. And if you want to have all the Wi-Fi 7 features working, of course, you need to have Wi-Fi 7 clients. At the end, I have a small overview of the clients that I have found. Not that you can actually buy them yet in most cases, but in any, but I have found some Wi-Fi 7 client devices. And the last thing that I want to mention is that it's quite interesting to have Wi-Fi 7 devices already, while it is only expected to be ratified sometime in next year. So one of the things that we're doing with Wi-Fi 7 is we are increasing the QAM, the quadrature amplitude modulation number of bits, and going from 10 bits to 12 bits, we get instead of the 1024 different points in the thing, we get 4096. It is a 20% throughput, but it is something for which you need to be very close to the AP. I've made some notes, like here. This is a feature that is already supported by the 526, or it will be supported when you get it. Not all of the features that are available Wi-Fi 7 are implemented from the get-go. The other thing that we have, although I have my ideas about how sensible it is for business implementations, is that we will have 320 megahertz bandwidth available on the 6 gigahertz. So Wi-Fi 6 can use 160 megahertz on both the 5 and 6 gigahertz band. Wi-Fi 7 can use 160 megahertz on the 5 gigahertz band, and the double of that, 320 on the 6 gigahertz band. In a single AP situation in Europe, you might want to use that, but as soon as you have a implementation of multiple APs and you have a plan, of course, with the 500 megahertz available bandwidth, with a 3-channel plan, it's only 160 megahertz that you can use for each channel anyway. So, like I said, it's not so much a improvement for us in Europe. The next thing that we can have with is the improved multiple resource unit usage. If you have something like 160 megahertz that you would want to use, but last 40 megahertz is already used by some other device, some other AP, then with Wi-Fi 6, you can only switch and go to the lower part, so only 80. But with Wi-Fi 7, you can actually reuse that in-between space to make full use of the whole spectrum. Then you get depuncturing. That's more or less when the user is in the middle of it, not at the end, but in the middle, or there is some interference there, then you can just avoid that part and still use the end part, even with a single user. In this case, we have shown 2 users here, but it could be the same user that is using both the front and the end of it. So you will have 50% more throughput compared to, or 33, depending on how you're looking at it, more throughput than before. The other things that are very interesting, or actually I think the most interesting things of those are the multi-link operation, or MLO. So we have 3 versions of that. One, to improve throughput, use multiple bands, multiple channels at the same time, and just load balance over those. According to the information I have, this is a function that we have supported from the start. But the interesting point is that maybe this is something that is very hard to implement on clients. So if we have this supported, we will mostly have that for mesh connections between 2 APs. Then you have the improvement of latency using multiple channels. So this might be a single radio device looking for a single radio client, which is looking for, hey, which channel is free? And then as soon as it notices that its channel is free, regardless of band, it will send the packets over to the access point. And the other way back also. Not needing to wait for a specific channel or a specific radio to be available. This can reduce latency. This is something I have been told that is not from the start, but apparently if I look at the information about clients, this might be one of the first things that is implemented on the client side. Then the multi-link operation to improve reliability. This is something for the future. And the idea here is you have multiple radios on the device and on the access point, of course. And you will send the same information on all available radios at the same time, just to be sure that a packet comes through. So the key benefits. Well, you have everything with Wi-Fi 6E. Well, wider channels, maybe. Of course, the 6 gigahertz by itself, adding the 500 megahertz of spectrum is nothing to sniff at, because it's more than a doubling of what we had before. We have 3 106 megahertz channels to play with. Although what I'm hearing for a lot of people is that it's more likely that you will use it as 6 channels of 80 megahertz in channel plans. But in any case, it's a big improvement. Also, the only thing that is preventing Wi-Fi 7 speed would be 6E devices, and those are already pretty fast. So what we'll get is, yeah, well, I'm trying to show here that we actually get a doubling of what we had before. Note that 6 gigahertz is in Europe, at least, is for indoor only. If you have any political sway, apparently lobbying for 6 gigahertz outdoor and also more megahertz for indoor is something that could help. One maybe important thing to notice is 6 gigahertz. It does not have any DFS. So you can actually use fixed channels without worrying about needing to move from one channel to another channel. So yeah, this is a repeat of what we just talked about. There's one thing I forgot to mention, which is also an interesting point. This is not just for 7, but also 6E. If you're using the 6 gigahertz band, instead of when you double the bandwidth, you spread all the power, the same power over more megahertzes. With the 6 gigahertz, you are allowed to use a more constant spectral power density. So if you double your bandwidth, you're also more or less allowed to double the amount of power that you're using. So the same amount of power for each 20 megahertz when you're doubling. So that's a summary. And of course, what we can expect is that Wi-Fi 7, well, of course, for the performance on 6 gigahertz, it's already pretty high from the start. But for the 2.4 and the 5 gigahertz, as the more clients come in with Wi-Fi 7 support, we can expect that there will be a improvement over time. So now for our new products. So I actually have one of those devices here. It is pretty big. It is well, I would say huge. It gets very hot, and it has a different bracket from before. I will show this some pictures, but to show it here, so there's a bracket. If you push on it, so if you push on the AP, you can rotate the AP and then remove it, and it you put it on and then to slot it in place. So that's yeah, I'm not 100% sure how much improvement the new thing is, but at least if you want to mount it to a flat surface, it's much easier because it has normal holes to mount. And if you need to mount it to a system ceiling, then there are some things to hook the bracket to the system ceiling too. There are some pictures about that next. Okay. So, well, of course, if you need more bandwidth, blah blah blah. So as you could see, we have this device actually has 2 ports, which you can use for chaining or for having for doubling your speed, depending on what your needs are. Oh, I made one mistake here. It's a BT PoE port, not an AT PoE port. It actually needs BT because it uses about 38 watts, and that's more than AT can support. So PoE++. It's 4x4 just like the it's like the 336, just a little bit bigger, and has a comparable yeah, well, it's slightly bigger, but comparable specs if you look at it. Then a little bit later we will have the 526. I don't have one of those yet. As you can see, it only has a single Ethernet port, and that will be a 2x2x2 device. That one does use AT and not BT. And the other things are comparable. So most of the things with the 526 and the 536, they are mostly the same, except that it has 2x2x2 ends instead of 4x4x4. So this picture of all the housings, although I hope that from the camera view you did get a little bit of idea how it looks in life. So what I have shown, the mounting plate, the rotate to click in place, and if you press on it, you can unlock it. If you just try to turn it, it won't budge. You really need to press on it, press on the AP into the mounting plate. And then for the ceiling, you have these two additional brackets to mount it to the suspended ceiling, or what's in the Netherlands we call a system ceiling. I have a product overview. You can see that a lot of the specifications for the 336 and the 536 are comparable, only the speeds have gone up quite a bit, actually. And this is because of the Qualcomm 4096, the 12 bits, the 20% speed increase compared to the 6. Now, we never had a ECW526, so a 2x2x2 for 6E, but we do have the 526 now. So BT 38 watts. For the cloud management, there's one interesting thing. They already decided it would be smart to add a disable the Wi-Fi 7 option on the radio settings for the different radios, just in case of problematic legacy clients, because we have to disable 11AX option because there were some, as I remember correctly, some Intel clients or Intel drivers who didn't like to see AX when they're only supporting AC, and then you could disable the AX to make those work. That was resolved, of course, with later drivers. This was no issue, but they included the same for the BE to make this work. The other thing is MLD list. So on the next screen, I have a mock-up. We do not have that in the cloud yet, but this is something that we will get. So the interesting thing is to make the whole MLO multi-link operation work, you actually need to have different MAC network IDs for the different radios in the same device. So you have a overall MAC address, and you have some sub MAC addresses for each radio. And when you have an MLO connection, the devices will see the upper one, but actually links will go over the sub ones. In any case, the interesting thing here is that we will be able to see for each of the links, each of the radios, the different speeds and what the different rates and different speeds and stuff like that. So that's that can be very, very helpful, especially when you have some issue and you need to debug it. Also, for 6 gigahertz, there are some changes. I think these have all been implemented already. And this has to do with the different combinations that are possible. In the past, if you enabled the WPA3, the 802.11r wasn't working anymore, but now you can select it. In some combinations, it is still disabled, but in other situations, you can optionally enable it. So some applications. Yeah, well, again, more high density. These are the same things that were for the 6E, because 6 gigahertz. Mesh connections. Just to show that that's actually possible. So I have my 536 connected, and I also have a 336. I don't have two 536s, but I have those two connected. It's not optimal. I didn't put them really close together. I actually have several walls in between, but still it's it has a gigabit link at the moment over the 6 gigahertz, which is I think kind of cool. So you could conceivably use it in this for this. And remember, in the past with 5 gigahertz, 2.4 gigahertz, if you increase your bandwidth, then your spectral power density will get lower. You will still have your whatever 20 dB power or dBm power, but then it will be spread over over each doubling of your bandwidth, so it will get lower, 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 and that will not happen with 6 gigahertz. So if you have built a mesh of devices, Wi-Fi 7 devices, and you put them just use your 6 gigahertz just for meshing. Maybe you could use the 320 megahertz bandwidth for that, and have a pretty good throughput on that, because it is not in the power density will be the same regardless of your bandwidth, or almost the same. I'm still looking at the numbers about that. So yeah, well, you can use it in schools for free Wi-Fi, of course, in gaming rooms, if you want to have less latency, more speed, hospitals, training centers, whatever, VR rooms, maybe especially those. But of course, your clients will need to support the 6 gigahertz unless you're using this for meshing. I found some competing devices. there's some interesting stuff here that I noticed. So with the Zyxel device, I see suddenly a larger number here for Wi-Fi 5, and I'm not entirely sure what the number is, because for a single user for a single user MIMO connection, this number is impossible. So they have, maybe this is a multi-user MIMO connection, and our numbers are all for a single user MIMO. Otherwise, you can see that from these devices, we're the only one with two 10 gigabit numbers. And if we actually get anywhere near these total throughputs, then you might actually want or even need the two 10 gigahertz connections. And if not, you can use the second 10 to loop to another AP, which is also nice. Although the other AP will need to be powered, because you can only power the first one. So that's that. Yeah. Wi-Fi 7 clients, which I talked about before. So I know that MediaTek will have two devices. Numbers are here. I'm not sure, but I guess AMD will also have their rebrand. I think I have some idea for how they would call them, but I'm not. Well, it's not confirmed. The interesting thing is that here you will have some devices that only allow 160 megahertz on the 6 gigahertz, and others that allow 320 megahertz. So if you buy a client to put in your laptop, to upgrade your laptop, be mindful that some clients do not support 320 megahertz, just 160. And although you might never use it, for us, the technique guys, we might want to be able to see the whole 320 megahertz in case somebody is using it, and also for testing. For Intel, there are two models at the moment on the Intel side, the BE200 and the BE202. Interesting enough, the lowest number, the 200, is the one with the 320 megahertz bandwidth and 4K QAM. The BE202 only has 160 megahertz and 1K QAM. So it will be quite a bit slower than this one, than the BE200. For the 200, I think that the Intel devices are actually already being shipped with some motherboards. But there's something interesting about that, and that is that for the Wi-Fi 7 MLO multi-link operation stuff, they're talking about that will be available for Windows 11 in the second half of next year. So that might take a little bit of time before we have it. Yeah, of course. Actually, I find the $20 €20 price for the B200 quite cheap. If you want it faster, maybe to Amazon. I've seen that for 50 euros, including shipping. So maybe you can have it before the end of this month there. But from Mouser, it would be end of the year before you have it, if Intel can ship that in time, of course. I have not seen any USB clients yet, but those will possibly also come later. So a little bit of a roadmap. So we have the 536, which will be shipping in December. Although we have a few, well, there are only 2 in Europe at the moment, but we will have, we expect that we can ship them in December to customers. The 526 will probably be a little bit later, maybe also December, maybe January. And I know there was a 556 touted, but this outdoor device, yeah, we're not allowed to use the outdoor 7 gigahertz. So what will happen here is not entirely clear. It may come to Europe, it may not come to Europe. Maybe they will change it that the 556 will also be able to do 2 5 gigahertz radios outdoor. That would maybe make sense, but I understand from my colleagues that that is hard to make it switchable from 7 gigahertz and have 2 5 gigahertz radios operate side. So a little bit in general, if you have any further questions about this or other things, then you could, if it's about cloud devices that you have active, please start a chat on cloud.engenius.ai. If and in those cases, supply remote support code, the organization, network name, and the device effective, please. If it's anything else, for Europe at least, send an email to support@engeniusnetworks.eu. For availability, pricing, orders, contact your sales contact. And everybody, thank you for joining and have a very nice day.